Hello friends, in this video I will be discussing objective 2 from Newton's laws of motion of the book H.C. Verma. My name is Hitesh Sharma. Let's get started with the first question. So a reference frame attached to the earth is an inertial frame? No, because the earth is rotating as well as moving around the sun in an elliptical path. So acceleration of earth is not zero. So it is not an inertial frame. So obviously option B is correct. Option C again is incorrect. Option D, because the earth is rotating. Yeah, these are the two reasons why we cannot take a frame attached to the earth as inertial frame. B and D are the correct options. In the next question, a particle stays at rest as seen in a frame. We can conclude that the frame is inertial. No, it's not necessary. As from a lift which is accelerating, all the objects which are accelerating within the lift uh, are appear to be rest, so lift cannot be an inertial frame while accelerating. So option A is incorrect. Option B says that the resultant force on the particle is zero. No, the particle might be accelerating, but it is at rest with respect to some frame. Okay, so we cannot say that the total force must be zero or acceleration of that particle must be zero. The option C, the frame may be inertial but the resultant force on the particle is zero. Yes, this is correct. If the frame is inertial and we see an object from that the particle is at rest, so the acceleration of the particle must be zero, hence the resultant force must be zero. Again, C option is correct, because when you will see from a inertial frame, if the frame is inertial, the acceleration of the particle is zero because it is not moving with respect to the frame, so the net force must be zero. And option D, if the frame is non-inertial, there is a non-zero resultant force on the particle. D is also correct, because when the frame is non-inertial means it is accelerating and you see an object from it which appears to be at rest, so the acceleration of the object should be same as the acceleration of the frame, so it must be accelerating. So the force on it, the real forces on it must be zero. Net real force must on it be should be non-zero. Okay, it must be accelerating, so net resultant of real forces must be zero. I'm not including pseudo forces here. Okay, so C and D are the correct options. We can also look at the solution. If an object is at rest with respect to inertial frame, acceleration of particle must be zero, F net must be zero. If an object is at rest with respect to a non-inertial frame, acceleration of particle must be equal to acceleration of frame, which is not zero because it is a non-inertial frame, so F net must be non-zero. We are including only real forces, not pseudo forces. A particle is found to be at rest when seen from a frame S1 and moving with a constant velocity when seen frame S2. Mark out the possible options. The particle, as the acceleration of particle is zero from both frames, so we can say acceleration of frame 1 respect to 2 must be zero. Okay, acceleration of frame 1 with respect to frame 2 must be zero. So either they are both inertial frames or both are non-inertial frames with same acceleration. Okay, so option A and B are correct. In the next question, there is a figure which shows displacement versus time graph, and we have to find that the force acting on the particle is zero in the region. In which region? We can say the force acting on the particle will be zero when acceleration is zero, and acceleration of the particle is zero when it is not when xt graph is a straight line. Okay, xt graph is a straight line means velocity constant. Velocity constant means no acceleration means no net force. So AB and CD are the part of the graph in which velocity is constant, acceleration is zero, so net force is also zero. The next question, there is a heavy block which is kept on a smooth surface. and this is pulled by two ropes of equal mass m at t equal to 0. The left this rope is withdrawn, but the force at the right end continue to act. Let F1 and F2 be the magnitude of forces by the right rope and the left rope on the block respectively. We have to justify or find which of the following is correct. F1 equal to F2 equal to F when t is less than 0, means when both the forces are acting. So obviously this statement is correct. When t is less than 0, the diagram FBD can say all this rope is at rest, so this force here must be equal to F, which is F1, and this is also at rest, so a force F in this direction must balance this force F2. So when both the forces are acting on the right and left ends of the rope, we can say all three forces F, F1, F2 must be equal. But next option is F1 equal to F2 plus mg for t less than 0. No, this is incorrect. For t greater than 0, as the system is accelerating, these forces will not be same. As the system is accelerating, when this force is removed, we can say that F acceleration can be given by total mass into acceleration. Force is given by total mass into acceleration F1, which will accelerating this rear portion which has mass m and small m. So F1 will be this, and F2 is the cause of acceleration of this rope only. So that will be small m a. So obviously F1 is greater than F2 and F is also greater than F1. So this will be the expression for t greater than 0. So A is the only correct option we have. In the next question, the force exerted by the floor of an elevator on the foot of a person standing there is more than the weight of the person. Obviously, the person must be accelerating in upward direction. So that case can occur in two ways. Obviously, if normal is greater than mg, then acceleration must be upward. So option B, this scenario can be taken in two ways. It is moving, going up and speeding up, so the acceleration will be upward. If it is going down, it must be slowing down, then only acceleration will be upward. Okay, the prime condition is acceleration should be upward, only then n will be greater than its weight. Moving on to the next question. If the tension in the cable supporting an elevator is equal to the weight of the elevator, then obviously the acceleration of the elevator must be 0. It might be moving up or down, it doesn't matter, but acceleration should be 0. So going up with uniform speed, going down with uniform speed are the correct option. Next is a particle is observed from two frames S1 and S2. The frame S2 moves with respect to x1 with an acceleration a. Let F1, F2 be the pseudo forces on the particle when seen from S1 and S2. Which of the following are not possible? Okay, the obviously one frame has to be inertial. Oh, sorry, at least one frame has to be non-inertial. Okay, because both are accelerating with respect to each other, so at least one. It might be the case that both are non-inertial frame, but at least one should be non-inertial, so both pseudo forces cannot be 0. Okay. Ninth, a person says that he measured the acceleration of a particle to be non-zero while no force was acting on the particle. He must be in a non-inertial frame, then only acceleration will be there even if there are no real forces. Okay, that acceleration that he measured will be because of pseudo forces.